it's not you are thinking about this as a motor, because what we try to do is if we have a rotating, the rotor is rotating by the push of this wind blade. So the wind push the blade is kind of like a prime mover. So this is a generator. And if we don't put this AC in there, we just use a permanent magnet on the rotor. That will be just a simple generator. Or if you put a DC to make this rotor as a magnet rotating, when a rotating magnetic field inside the stator winding, it will induce the voltage on the stator. But because if you have a DC or you have a permanent magnet down here, the prime mover, with the certain speed from the prime mover, you can only generate certain voltage and frequency on the stator. But we want that stator voltage and the frequency is constantly at what we require. But the speed of this prime mover, we have no way to control it, because sometimes you have big wind, sometimes you have smaller wind. Yeah, so instead of putting a DC in here or using a permanent magnet down here, we put a variable frequency AC in here. That's about a motor. When you have a round rotor motor, you put a resistance on the secondary circuit, you try to increase the starting torque. But here, we just need those rotor winding have a connection outside, so we can feed a different frequency and the voltage AC in there. One more you learned about it is a synchronized motor, right? The synchronized motor, you also have a rotor winding. You can put a DC in there, but for you putting DC in there, you can only generate the certain frequency of the voltage, the AC out on the stator. It's kind of using the same kind of machine as a round rotor motor, but in here we use them as a generator. It's not a motor. That's why we don't have the resistor down here. We put in a different AC in there. We can talk about this one in more detail if you. Yes. Yeah. So that's true. So we use that AC signal in there to working with the rotating speed of the blade moving by the wind to keep constant output voltage on the stator. No, the stator is the output. In second year, we start learning AC generation. We usually tell you, we say that we have a magnetic field, then we have a coil of conductor. If this coil of conductor is rotating inside this magnetic field, we will generate the voltage on the coil, right? But then we told you, we said, okay, for the real big generator using by the utility company, actually is we have the winding, stator winding is the armature, because we try to generate the voltage on there. Then we have a electrical magnet is rotating inside. Here's your stator winding. The stator winding, we have a bunch of coil down here. Then we just use some brushes and commutator. We put a DC current into this rotor, because for this DC current, when we have a lower current, we have many turns of coil, we can creating a stronger magnetic field. But because it's a low current, so your commutator, those things, you don't need a big size. But if you try to using the armature to generate the voltage on there, you generate a high voltage, high current, and your slip rings or those things have to be very large size. So the same thing down here, we use a rotating magnetic field in here to generate the voltage on the stator. Yeah. Okay, now we have 44 people here. Anyone have any question? If you guys have a question, you can ask me for now. If you don't, I will go to where we left over from yesterday. So yesterday we go past here. Utility scale. Can you specify that? And Lucky? Smaller wind turbine and a larger wind turbine. That's a code definition. When we go through certain code, so make sure you have your code book ready. I guess you guys write the exam, you needed the code book. So smaller and the utility in D2L. Oh, on the SCORM. I guess the SCORM is made in the America, and because they have more resource to make those learning, and they move into Canada, they do that, but because in Canada we using the CEC code as the definition to identify which is a large wind turbine, which is a smaller wind turbine. So you don't have to, like the SCORM, they might give you a different definition, but if you know in Canada, what's the large wind turbine, what's the smaller wind turbine, that's good enough. In Canada, we also have a definition we call the high voltage, low voltage, and the extra low voltage. It doesn't mean for the utility you have to go above 750 volts, because in Canada here, usually the normal voltage we use in distribution is 600 volts for the maximum. You can kind of have a 208, 3-phase or 600 volts 3-phase. It's pretty common. Some places you will have 480 volts 3-phase. I wouldn't worry about that 750 as for the utility. You're welcome. I think yesterday we talking about this one. Then I mentioned something about that inverter. We're gonna talk about that one slightly later. So here is something we're talking about. Because the cable coming down from the tower, when the nacelle cable rotating, you might be able to over twist the cable. So you usually either have a turn count. Most of the time they will have both, because even one device is not functioning properly. You have the both, you will for sure to protect you. The chance for both of them not working is very small. So one is for the turn counter. Nacelle simulator, we're going to show you slightly later on. It's a piece of equipment we're using to teach those renewable energy course. So one is the turn counter. They will count every time the top of the nacelle keep going for the one direction. If you go counterclockwise, you're reaching, they said when you're reaching about 12 turns, they will automatically activate to unwind the top. Another one is a limit detector. It's somehow test we sensor the tension on the cable. If the tension become too tight, they will also send the signal to unwind them. It's both controlled by the PLCs, and here tell you 12 turns is where they designed in there. In the real wind turbine, they might have you probably can change how much turns you can go into the PLC to control those things. Here's one more thing. It's when you do those online quizzes, one of the questions is going to be ask you. They said, what's the common one to connect a wind turbine to the utility power grid? The right answer is the shunt trip circuit breaker. The shunt trip circuit breaker in here, they put a emergency stop button that could work. And another one is they have an actual coil. So you could put like an emergency push button to disconnect your wind turbine. Also, you could use a PLC to remotely to trip the circuit breaker or disconnect the wind turbine from the utility grid. Because usually those wind turbines are located at a remote area, remote place. If something goes wrong, when you try to send someone go there to disconnect them, you're probably going to take hours, sometimes even days. So if we're using the shunt trip circuit breaker, is you can in the central control station, you can basically send a PLC signal. They can trip the circuit breaker to disconnect them. So that's why I add these slides in here. It's for you to answer one of the questions on your quizzes. Another one is called the wind turbine the power curve. It's because when the wind speed is too low, for here they give you this is a piece of diagram I copied from yeah, I could do that. This is a diagram I copied from one of the website. So for their wind turbine, if the wind speed is below 8 miles per hour, there's too little power to generate. So the wind turbine will never turn. So your wind turbine just in the in the stationary. They're not gonna be moving the blade or do anything. The blade is locked by the brake. But once the wind speed go over 8 mile per hour, that one called the cutting speed. So now you can let the blade to move, start generate some power. They have a rated speed and a rated power. So this one is rated at 31 mile per hour. If the wind speed reaching that, then your wind turbine will generate rated power all the way to when the wind speed reaches 55. Then the speed of the wind is too high for the turbine to operate safely. They will feather the blade and they will stop it. So that's where we consider. I usually upload updated one, but this one they probably copied from another course. They might not have the updated one. After this one, I will update this one, upload this one on there today. Okay, another one is in your in your online quiz. They talking about one is called furling, and another one we call the feathering. The feathering is for the large size wind turbine, and the large size wind turbine, they have those blade pitch control, so they can move the blade to different angle to facing the wind. But for the smaller wind turbine, they don't have the pitch control, so the blade was fixed down there. What they do is when they have a very strong wind, is they will turn the whole blade away from the direction of the wind. I leave the 2 YouTube video on there. You guys can check them out because I know you don't have them right now. But once I updated this PowerPoint on there, you probably can see them. So you can try to check those YouTube videos. They will explain those things. It's not important for your exam for this part. Feathering is we talking about large size wind turbine. We need it. But for the furling, it's just for one of your quiz question. They didn't mention anything on the score learning, but the quiz question have those type of question in there. That's why I put this one here, so you will be able to answer those type of questions in the quiz. Then there's a bunch of code requirement. We're not gonna talk about too detail in here, but we will have a full section to cover the whole section 64 of the code. So in here, they talking about the special terminologies in the beginning of the section 64. What's the multiple? You have a wind turbine down here, so you have a different kind of disconnect means how you're gonna put a different label in them, how you're gonna connect them. It's all in the code. Usually for the interconnection, they show you a picture about the label. So when we go to the code, the code will not give you this, right? The code just said you have to have a label to have a certain thing on the label. But if you try to say what's gonna be on the label, you can use this picture as a reference. So those are the warning notice or label according to the code. This is a smaller wind turbine. The smaller wind turbine, you can see this is not very tall wind turbine. And for those blades, they don't have the pitch control. So they just fix down there And this one is not very tall install. You can see the building down there. It's not taller than the building, so it's probably not gonna be very efficient. Large wind turbine, they have the nacelle on top. Here is what's inside a typical wind turbine nacelle. They have lots of equipment inside. Usually come here, student will ask me, oh, do I have to remember all those things inside? Do you guys want to remember everything inside? No? Okay, you don't have to remember everything inside. Unless you get a version F exam. Working on wind turbine, you guys saw the video. It's tall, it's high, and you have a crawl space. So there's lots of safety hazard related to the working that. But you usually will have the proper training, and you need to get proper training to working on those. So the safety thing, I'm not gonna talking too much. If you're working in that industrial, you're gonna probably get lots of proper training before you. Just like if you're working for some company, they usually have a more strictly safety regulation or anything related to you have to follow. I remember when I working on the job site every morning, you're probably gonna have a safety meeting to discuss what gonna be, or you at least you need to fill out a form relate to what you're gonna do today and what type of hazard you will encounter, and how you can preventing those dangerous situation happens. It's on I think a PCL's job site. You always have to fill out one of the form in the morning. So for those safety things, I'm not gonna talking too much. And if you guys want, you can read those in yourself. You don't need me to read them for you. So this is the one we kind of mentioned yesterday. This one is now using the doubly fed induction generator. This is a PM is a mechanical power coming in. You have a three-phase either synchronized or single-fed induction generator. So because the wind speed is changing, so this generator gonna generate something we call the wide AC. So it will have a variable voltage and the frequency. For this one, because we try to connect onto the power grid, but this voltage and the frequency is not constant at a certain value. So we bring into a converter, AC-DC converter. It's just a three-phase rectifier. You guys learned in third year. A three-phase rectifier, you're gonna change that into a DC current. Once you change it into the DC current, then you have an inverter down here. A DC AC converter is just a inverter. Then you change back to whatever required on the grid. So you might require 600 volt, 60 hertz here. The output of this inverter doesn't matter whatever. Usually you require a certain amount of DC voltage and the current here, but the whole thing you pick up here, it will be matching whatever your generator down there is. So the output will be steady voltage and frequency. It will matching with the whatever the grid on here. Also for those inverter, they will synchronize with the AC voltage and frequency on the power grid. For those synchronized motor or single fed, the only thing is from the synchronized, it's a generator. Yeah, so because here is the variable voltage and the frequency, that's why we call them the wide. It's like a WILD. It's now, yeah, considered it's uncontrollable. Yeah. The thing compared to W-fed induction generator is this converter part down here. If your wind turbine is rated for 100 kVA, this conversion down here need to be handling all the power for 100 kVA. So that's why they need a large size of this, gonna become expensive. But this is the most effective way to do it. Your control is simple. You just need converting them and invert it back. So remember, this is the best. To use. Yeah. So W-fed, you can use smaller size. You can save on room, save on money for this rectifier and inverter part. But that will come with much more complicated controls. So in this case, the three-phase current come out of the generator, rectifier inverter back to AC, compatible with the grid, enable the generator produce power at a lower speed. A wind turbine, it's not gonna have a very high efficiency. Like they said here, the wind have a total power about, just an example, right? 3,046 kilowatts. The rotor efficiency, we watched the video yesterday. The one told us because we can only catch so much wind. And so in here, they give you the rotor efficiency only 44%. And then the bearing, the gearbox, the generator, they all have an efficiency. Then you have a frequency converter, other type of filter, electronic circuit, and come down to the transformer. The output power for this one is only 1,176 kilowatts. So compared to that, the total efficiency is pretty low, but mainly is because how much wind power you can catch up. Yesterday, they told you that the band's limit is only 59%. So other than that, you can see other things have a pretty high efficiency, but still, you can only catch so much power from the wind. Here is that nacelle simulator or trainer. So I think someone asked this question before. Correct, right? So that's the one. Yeah, this is the one at the BCIT. We use this one to teach the part-time course for the wind power. So they have a bunch of here is the bottom is the yard control, so they can rotate to follow the wind direction. Here is the blade. We also have a pitch control. Oh, this one is I think the equipment we had for those renewable energy course is more than $500,000. So this one is pretty much 30 or 300 or 400K. You can buy one, put it at your home to play with it. Then the side here is a box with a PLC control inside. This is a human-machine interface. You can set in the parameter, set in the wind speed. They have some manometer for testing the wind speed and the wind direction on top. So it's pretty cool equipment. They have a lot of hydraulic stuff inside also, because all those brake is activated or controlled by the hydraulic system. The electrical system send the signal to the hydraulic pump gonna run, and there's solenoid valves to control if you want to apply the brake or you want to release the brake. Gonna keep going. So anything about the hydraulic system, it's not gonna be on your exam. But I gave you the whole PowerPoint down here. Is the PowerPoint first is created for the part-time course, but then because this year we start to have the harmonized program, we have the year 4 you have to study those renewable energy. So we made a little bit of adoption. But if you're interested to take in a part-time course, that's why I gave you the whole PowerPoint. You can look at them. But anything about hydraulic is not going to be on your exam. They will have a different kind of cylinder, how they control them, and you have those are all hydraulic systems, so I'm not going to spend time to explain them to you. You might have one of the questions on your working sheet. It can ask you what type of electronic device this check valve. So the check valve, you can only let the oil go one direction. It's kind of like a dial. Another one is called a relief valve. Relief valve, I don't think they ask you, but a relief valve is when the pressure getting too high, they will become open to let the pressure regulate the pressure. So it's more like a Zener dial, or you can call MOV. You guys learned MOV in high voltage, right? Yes? No? What's a MOV?
Yeah, I don't recall that.
Metal oxide varistor? No?
No.
So when you're working on high voltage, what if you have a lightning strike? What you try to protect your line? Lighting arrest, okay. Lighting arrest is they didn't talk about the detail in there. Why when you have a regular voltage is not gonna be have a problem, but when you have a super high voltage, that gonna be the lighting arrest gonna be leading those high voltage, high current to the ground. No, you guys never heard of those terms? Yeah, so that's a MOV. It's called a metal oxide varistor. It's you have a variable resistance value. only when the voltage go over a certain limit, the resistor value will become really low. Okay, it's not my topic. I'm not gonna say too much, but that's where they use them to protect that. Okay, so those are the hydraulic system. You don't need to worry too much about them. For some safety, the hydraulic system, one thing you probably, it's extra knowledge is good to know, is some of them is hydraulically released and the spring applied. So this is for the fail-safe reason is because if let's say you lost power or lost the hydraulic pressure in the system, but you still want that brake to apply, so you put a spring will apply the brake on. This is the rotor brake. So if you don't want the rotor to rotate, even you don't have the hydraulic power, the rotor is still gonna lock. If you want the rotor to move, then you have to apply the hydraulic pressure to release the brake. Another one is the yard brake is different. They use the hydraulic pressure to apply and released by the spring. So those are two different, depends on which one you want to the fail-safe kind of reason in there. Because the rotor, if you lost power, you don't want it to move in case there's a high wind or something. So it's hydraulically released and the spring applied. But the yard brake, because yard is controlling the nacelle to moving. So if you lost power, you don't have the hydraulic pressure, but your spring will let the yard go freely. So if you have a wind coming in and your yard will still got pushed by to move, that's okay. Now those things you don't have to know them. I guess this probably the anyone want to take the version F exam? You need to know this hydraulic circuit. So this is on the screen. No, nothing on the IP will test you this. The IP, I think this time the IP question is made by Ontario. Ontario have lots of photovoltaic, those PV system installed. So you mostly IP question, I say mostly, not all of them, it will be related to the photovoltaic. And this is the hydraulic system down here is over the requirement for the apprentice, electrical apprentice. So don't need to know them. Okay, I guess that's it. We don't need to go over onto this one. Okay, so like I mentioned, some basic thing. I told you, I said, oh, you have to know this. That's important. Those things you have to know. The hydraulic system for sure is not going to be on your exam. You don't need to worry about. Nothing about the hydraulic system will pop up. Unless you want to take my part-time course. You don't need to know anything of that. You guys okay for the wind power? And I heard, I think Trevor told me yesterday he tried to study that Scrum learning. He said he goes through about 30 or 40 pages. He already take notes for 6 pages. He studied very detailed. I mentioned to him if he like to get to know a lot of them, that's fine. But it's up to you guys' judgment. You probably don't need to know all those smaller details, right? He write down each component in there and what it does. He's a good student. I said I probably should find him some extra mark.
It took way too long though. Just saying.
Make you feel looks bad? Yes. Oh, you did the same case. Yeah, so usually I would say I wouldn't suggest you guys to do that. I had a class of students. They go through those one and they take a screenshot of each of them. Then they compile them into a PDF file. So they have all those things. Each of the screen in the Scrum, they have they put them into a PDF file. It's a large size of file. Easy for reference, but it's okay, whatever the way you guys want to do. So that would be 8 questions came from that online quiz relate to, but the online quiz you have 4. I think PV have 2, wind turbine have 1, and another one solar thermal have 1. So that's the total things you probably use your time wisely. Okay. Any question on the wind turbine? Otherwise, we're gonna go to a new topic. Nope. Okay. So next one we're gonna talking about is the geothermal. Geothermal energy is using the heat energy inside the Earth. Industrial use because there's usually have an underground like a hot spring or those one. They have a very high temperature, either steam or water. They can drill wells to extract those steam or hot temperature water to push a turbine. They usually after push the turbine, we feed those well back into the reservoir because they have to replenish the water or steam down there. But go through this process, the temperature of those things gonna drop, and because usually when you have a steam will have a high pressure to push the turbine, and they can use them to generate electricity. That's the industrial use. There's a different type of those wells, those generators. In this course, we're not gonna focus on the industrial use. We're gonna focus more on the residential and the commercial use. The residential commercial use is we're gonna use the geothermal energy to do heating and the cooling of the house or building. I can show you guys one video first. It's easy for you to understand this thing.
What if there was a way to heat your home in winter, cool it in summer, and provide abundant hot water all year round, all while cutting your utility bills by up to 80%?
Whether you're building dynamic network models or forecasting real-world behavior, Neo4j's new graph.
How? By installing a Climate Master geothermal central heating and air conditioning system in your home. Here's how it works. Wherever you live, the temperature beneath your home remains constant, regardless of the season. Just a few feet down, the Earth is a consistent 55 degrees, summer or winter. Climate Master geothermal heat pump systems harness this stable underground temperature to provide heating, cooling, and hot water at remarkably high efficiencies. So high, in fact, that energy use can be cut by up to 80%. To access this stable underground temperature, a geothermal heat pump is connected to a series of underground loop pipes. These loop pipes are made from an extremely strong and long-lasting material. Water, usually mixed with an environmentally safe antifreeze solution, is pumped through this loop pipe system. In summer, the heat pump takes heat from the air in your home, transfers it to the underground loop system, which then radiates the heat away into the cool earth. Now cooled to a comfortable temperature, the air is circulated through your home using a traditional duct system. In winter, the system is reversed. Heat is extracted from the ground using the same loop system. In the heat pump, the heat from the underground loop is compressed to a much higher temperature and used to warm the air in your home. Since a geothermal system uses an earth loop to provide your home with heat in the winter, there is no need to burn any fossil fuel for heating. No flame, no carbon monoxide, and environmentally friendly. Geothermal systems are the smart way to heat and cool your home. Let's compare a high-efficiency gas furnace to a geothermal system for heating your home. A high-efficiency gas furnace will give you less than 0.96 units of heat for each unit of gas burned. In contrast, a geothermal system gives you up to 5 units of heat for each unit of electricity used. How can that be? A furnace makes heat by burning fossil fuel. A geothermal system doesn't make its own heat. It simply collects heat from the earth and moves it to your home. Now let's compare a geothermal heating and cooling system to an air source heat pump for cooling. When it's hot outside, an air source heat pump takes heat from your home and moves it to the outside air. As the outside air becomes warmer in summer, it becomes harder and harder for the system to dump heat from your home into the already hot outside air. Because of this, when cooling a home with an air source heat pump, the system becomes least efficient when it needs to be most efficient. A geothermal heat pump system doesn't have this problem. A geothermal system exchanges the heat in your home with the cooler ground using its underground loop system. It simply doesn't have to deal with high outside air temperatures the way an air source heat pump does. Add to this the fact that a geothermal system is installed safely inside your home with the loop buried underground. Unlike an air source heat pump, there is no outdoor equipment exposed to the elements or the risk of vandalism. Let's take a look at geothermal loop systems. There are several different ways to install a geothermal loop system. Where space allows, horizontal loops are the most cost-effective loop design for most homeowners. If space is limited, a vertical loop system is often the best choice. If a nearby pond or lake is available, a coiled loop system can be used. This is the fastest, easiest loop system to install. If a well is available that produces sufficient volumes of water, an open loop system can be installed. An open loop system takes water from the well, pumps it through the heat pump system, and then returns it to the environment in a responsible, renewable manner. And geothermal systems don't just heat and cool your home. They can also provide you with hot water. Besides a nice shower and washing your hands, you can use the large volumes of hot water a geothermal system can produce for radiant underfloor heating, or even for snow and ice melt under your walkways and driveway. A geothermal central heating and air conditioning system from Climate Master can be installed in almost any home, new or existing. They can be installed in an attic, garage, or utility closet. Or, in the case of a retrofit installation, they can even be installed in place of an old outdoor air conditioning compressor section. There are even more ways to save with a Climate Master geothermal system than just lowering your utility bills. You can save up to 30% off the total cost of installing a Climate Master geothermal system with a federal tax credit. Additionally, many states and local governments and utilities also offer incentives for installing a geothermal system. As the world's largest and most
it's a good system, but we were talking about the initial installation fee is pretty high because you have to, if you can do it yourself, like especially you have a large farmer and you can dig trenches to lay those pipe down, the installation cost will be lower. But if you hire someone to do it, you know the labor cost here is it will be, because for the proper installation, they will be calculate what size of the heat pump you require, how many loops, how many fees are, how many loops or how many holes you have to dig. I can tell you one thing. That's before I come to BCIT. I working on, I think called the Surrey Civic Center, the new city hall. They basically, the whole building, they are using the geothermal. They use the geothermal to do the heating and the cooling. Yeah, but they are on the commercial and it's a government building, so they probably apply lots of incentive down there. They drilled, I think, close to maybe 100 or more than 100 holes on parking P3 down there. They drill vertical holes, and also between the civic city hall and the library down there, there's a big open space. Also have some parking down there. Then they have a horizontal pipe laid down there, and they have a room, about a pretty big room. It's all those pumps, pipes in P2. I guess it's P2. Yeah. So you think about the whole city hall is heated or cooled by that geothermal system. For them, they usually use the thermal fusion tools because all those pipe you put under the ground, you don't want to, if they leak or something, it's really hard to replace or repair them, right? So they use the thermal fusion. When they fusion the two pipe together, they said it's much more stronger even than the pipe itself. That's how they connect all those different pipe together. This is calculating the heat pump and heat transfer. We're not going to use this complicated formula. We're going to use another different formula. I'm going to tell you a little bit later. Most thing is almost the same, but we're going to talk about something different. Environmental advantages, like the guy said, you don't burn any fossil fuel, so there almost no CO2 carbon dioxide emission. And they have someone comparing. They said electrical plant product 13.4 gram of carbon dioxide per kilowatt hour. If you're using natural gas or you're using oil and the coal, that would be much, much higher. Also, they don't require lots of land. 400 square meter can produce gigawatts of power. And also they can be stay online for longer time. They don't have to have lots of shutdown time. by a comparison, the geothermal will be the lowest to have a CO2 emission. So it's a very environmental friendly. And if we want to go green, the plant can be online more than 90% time. Other plant, you always have to shut down to do maintenance. The heat pump, this the video tell you, because the video is the sales video, right? They explain things to you. They said that they can have 5 times more than you use electricity to circulating pump those things. Most of the time, the ground source, the typical efficiency is about 250 to 350. And for air source heat pump, you can only have a 130 to 200. Electrical, because if you use electrical heating, all the electricity will convert to heat. But if you use gas or something, you always lose a little bit of heat because you're burning them. There's a CO2 or those little bit of heat will be exhausted out. The initial installation cost for the geothermal heat pump is pretty high. So they said per kilowatt heating, how many dollars you're gonna put. If you have a boiler, you're probably just gonna put in $25 to $200 per kilowatt heating. Furnace is pretty cheap, or electrical heater between 30 to 80. But the geothermal depends on if you, especially vertical drilling, is going to be costing a lot because you can't do those yourself. You have to hire a special company. The vertical drilling usually required, it's sometimes they drill the hole more than 100 meters down there, and depends if you have lots of rocks down there or something, the drilling cost will be pretty high. But that's for when you have a limited area, you can put those things down there. The horizontal, if you, let's say you have 10 acres of farmland, you just have one building on there, you probably just can driving some kind of machine yourself to dig the trench and lay the piper down there. And so it will be a little bit cheaper. So the initial cost, that's the major things stop people putting those type of system in there. If the initial cost will be dropped down more, and this will be a very good system because you don't pay for the natural gas, you pay a little bit for the electricity. You can heating and cooling your house to a pretty comfortable. There is government incentive. If you can get them, that's the best. Okay, here is something important. About those geothermal systems, they have a closed loop and open loop system. You guys remember in the automatic control, we're talking about closed loop and open loop system, right? And the difference in there. But when we're talking about open loop and the closed loop system in a geothermal system, it's totally different idea. The closed loop system down here is you have a complete loop of pipe buried under the earth or something. You have a water and antifreeze. Usually you have an antifreeze solution circulating through those pipe, and you try to bring the heat up or go to the earth. This is considered a closed loop system. The open loop system in here is if you have a pond or lake or something, you just extract the water from the pond, from the lake, or even underground water to use the water. Then you bring the water, go through your system to do the heat exchange. Then you discharge the water into the lake and the pond. So usually the open loop system there, you have to, if you want to install them, however, they have to get some kind of special permit, because in Canada here, it's not say the water is belong to, I think, a federal government. You have to get a permit from them. It have to be environmentally, you're not causing any pollution or anything to the water before they will give you the permit to use on them. But the important thing down here, this open loop and the closed loop is totally different than the open loop or closed loop we're talking about in automated controls. Okay, so Hayden, are you gonna make this question wrong again for open loop and closed loop? He falling asleep, or he disappeared. So this is important. Okay. If you answer this question wrong, I'm gonna drive into your house, give you a private tutoring. There's one system installed in the Olympic villages. They also use the geothermal. That's one, it's pretty early, I think, when we holding that Winter Olympic in Vancouver here, they already installed that one. The one I know is for the Surrey New City Hall. They use that. Can you guys hear me? You guys still there?
Yeah, we can hear you.
Yep.
Oh, okay. Okay. I just kind of feel too quiet. Okay, so here is another very important things down here. Okay. I strongly suggest you have this picture ready when you're doing the exam. There will be question asked about this. So a heat pump system principles. The heat pump, this is a simplified drawing. They give you 4 components: condenser, evaporator, you have a compressor, you have an expansion valves. What this heat pump like we call heat pump, or we call this a refrigeration cycle. So it's the same thing in your fridge. They have an evaporator. They have some kind of, we call the refrigerant. And we're gonna slightly tell you a little bit more on this one. But when the refrigerant come here, it become a low pressure, low temperature liquid when they go through the expansion valves. And when those liquid, they will evaporate in here. They're gonna change their state from the liquid into a gas or vapor. When they change the state, they need absorbing lots of heat, because we need the latent heat of evaporation down here to change from a liquid to vapor. So the evaporator gonna absorbing lots of thermal energy or heat from the surrounding. So they change from liquid to vapor. Then go through the compressor. The compressor going to be compress those low pressure vapor into a high pressure, high temperature vapor. When they change from when the vapor goes through the compressor, the pressure goes higher, the temperature goes higher. When the pressure goes higher, those vapor gonna try to change back to the liquid. So they're gonna release those heat called the latent heat of vaporization, because the boiling point is related to the pressure. So when they change from vapor to liquid, they're gonna release those heat. When they release the heat in the condenser gonna release those thermal heat energy to the surrounding. So here basically we absorbing heat from one side, then we can release heat to another side. So depends on in the winter or in the summer or in your fridge, is it inside or outside. So in the summer, you probably want to absorb the heat from inside, then release them to the outside or release to the ground. In the winter, you're gonna absorb the heat from the outside or from the ground, then release them on the inside of your house. So that's how a heat pump is working. You guys, for this picture, you have to know which one of them is absorbing the heat, which one of them is release the heat. So you're never working on those kind of system. That's why I said I suggest you have this picture ready when you're doing the exam. You 100% you're going to encounter question ask you about which one is going to be absorbing the heat, which one going to be releasing the heat. We clear on this? Yes. I'm gonna stop here for a second because I need to cover something. It's not on the any of the document, but you have to know for the exam. You guys want to take a break first, or you guys want me to? Because it's gonna take a little bit longer to explain the stuff right now. Yeah, so let's take a break. And we come back at a 15-minute break. 9:23. I think you can either, I can go back to that page if you want. Okay, I will see you guys in a bit. Okay, you guys back?
Yep.
So, saw case ask the difference, but okay, here's a, if we have a closed loop, here's your building. Here's your, let's say, this is your heat pump. You have those plastic pipe. So the pipe gonna be buried underground. This is horizontally, or you can have the pipe go down here, then you go deep into the ground. So you have a complete piping system. That's the closed loop. If you have an open loop, here's your building. Then you have a heat pump down here. So you need to have a lake or a pond. Then you're gonna take in the water from here. So water goes through one pipe, go there, and after the heat exchanger, you're gonna release the water in there. So this is not a complete piping system. You suck in the water from one pipe, you discharge the pipe water through another pipe. Yeah, so, or another one is, here's the ground. You have a underground, either you could be a lake or a river. Then you can also take in the water from one pipe, then discharge the water from another pipe. Or you can even take the water from here, discharge to another place. So as long as your piping is not complete, because this one, you have a complete piping system for those water or anti-solution to circulating down there. You're not going to be changing those things from the anything outside. But here, you are changing the water. You basically open loop, you only use water. You're gonna take in the water from one and you release the water back. That makes sense now? Yes? No? Okay, hope that makes sense. And if you're using them in the winter time, at least because if the whole lake is frozen, you can't do anything, right? But still, water will have more, they call it specific heat capacity. So even the top of the water, let's say the top layer of the water is frozen, so become ice, but below there, if still have water at a few degrees. So as long as it's not totally frozen, it will work. But the best way is still, you put them under the ground here, because if you go down about 10 to 15 meters, and the temperature here is always 10 to 12 degrees constantly. It's not changing. And when you dig those trench down deeper, you might reach somewhere much warmer. So the closed loop system is we say it's a preferred way. And even you have a underground lake or something, because anything inside this open water system, you will causing this deposition of some chemicals, will block your heat exchanger or something. You use the closed loop system, your system probably lasts longer. And the open loop system, because the things contained in the water system, it might cause your system have a shorter running time. Can I answer your question, Case? Okay. So gonna talk about heat energy. So heat is actually energy. We call it thermal energy. There are three common methods of heat transfer. The first one called conduction. Conduction usually happens in a solid piece of material. That's a very usually. Sometimes it can happen in liquid or gas, but the conduction is you need some, we call this a medium. Medium. So if this side, they're usually gonna be solid. So if this side have a higher temperature, this side have a lower temperature, the heat energy will always transfer from the high side to the lower side. Yeah, you need through some kind of medium in between. So usually if you have a, let's say you have a solid piece of metal or something, metal will be have a much more quicker. So if you put some kind of burner or fire under this side, it will increase the temperature on this side, but through this piece of solid material, or the heat will transfer to the other side. So this is considered conduction. Second one, they call it convection. Convection usually happen is when you boil the water. So you try to boil in water. Convection usually happen on liquid or gas. So when you put the heat energy at the bottom of the water, they will become warm. When they become warm, they will become less dense. So they will try to rise to the top. And the top one is cooler. So the cooler is more dense. So they will come to the bottom. So they will kind of become a circulation motion. The warm, less dense one will rise to the top. The cooler, more dense one will come to the bottom. So you have a circulation, a cooking kind of. So it's usually happen on the liquid and the gas. This is considered convection. Certain thing, they have a forced convection, or certain book will tell you another one called advection is when you have a wind, or you have a ocean current, try to move to do the horizontal circulation, the convection. The certain book have a different name, but for us, we don't need to care about this. We just need to care the three common method. So this is a convection. Third one, it's a radiation. The radiation is, they call the electromagnetic waveform. So we have two pieces of material. Maybe this one is at, let's say, 10 degree. This one at negative 10 degree. The one have a higher temperature will radiate more heat energy. The one at the lower temperature, they also radiate heat energy, but it radiates less heat energy. Getting better? And also my handwriting is terrible. So the higher temperature one will always radiate more heat energy. The lower temperature one will radiate less heat energy. But any subject or object, as long as they are above absolute 0 degree, the absolute 0 degree is negative 273 point some degree. So as long as you're above that degree, they always radiate heat energy. Then for other object, they radiate heat energy. They also receive the heat energy by radiation from other or any object surrounding them. Then I think in automatic control, we're also talking about if a black body, they will receive all the radiation energy from other object. If a white shiny body, they will receive less because they reflect a bunch of them out. So here are the three common methods for heat transfer. This is the things you're not gonna see them on any PowerPoint or anywhere on the D2L, but probably gonna on your exam. We good for this one? Yes, no? Good, okay. Then we're gonna talking about something else. It's called latent heat. There are two types of latent heat. Latent heat of fusion. It's for a subject or material changing the states between solid and liquid. We're going to explain this one a little bit later. Another one is latent heat of vaporization. So it's for the, okay, it's the heat energy required for subject material change state between solid and liquid. This one is the heat energy required for a subject or material changing states between liquid and gas. So we take water for example. At let's say -10 degree, the water gonna be in the state as ice. So that's solid. If we put heat energy in there, first this ice have to increase the temperature. That heat is considered sensible heat. The sensible heat gonna make the ice temperature increase. So the sensible heat gonna make the ice temperature increase to 0 degree. Once the ice temperature reaches 0 degree, it's gonna be absorbing the actual heat. Now we call the latent heat of fusion. The latent heat of fusion gonna start making the ice to melt. So now you have ice and the water mixture. Until all the ice melted to become water, that's all the heat considered as the latent heat of fusion. You need absorbing lots of those latent heat of fusion to make ice become water. So now you're gonna have a water at 0 degree. That's the liquid. You're putting more heat in there. Now become the sensible heat again. The sensible heat gonna make the water temperature to increase. Under normal pressure, you put the sensible heat, you can heat the water to 100 degree. Once the water reached 100 degree, you're gonna start to evaporate. Now the actual heat is become the latent heat of vaporization. The latent heat of vaporization gonna make it become water and the steam mixture. Until the last drop of water all become the steam, then you will have 100 degree steam now. Then you can put more heat in there. This time become the sensible heat again. You can heat this steam to a high temperature, let's say 110 degrees. So this process can be reversed. So first, you try to cool the steam down from 110 degrees. They're gonna release those sensible heat. When they reach 100 degrees, then they're gonna release the latent heat of vaporization to become a water and steam mixture until the last bit of the steam all become the water. Now we have all the water at 100 degrees. Then you can take out those sensible heat or you release it. The wind temperature will start dropping, and in between 0 to 100 degrees, the water is in the liquid state. Then once reach 0 degree, it will become ice and the water mixture. You release the latent heat of fusion. Then you become a solid ice at 0 degree. Then you can cool it down more to become a solid ice at negative degree. So when it becomes steam, that's the gas state. So that's the three states of a material: gas, liquid, or solid. So latent heat of vaporization, latent heat of fusion. That's two important things to know. And for those latent heat, that's okay. Bring the paper up a little bit. Can you see it? Okay. You want the whole page? Are we good? Okay. So, away. Try to bring close. To do a comparison, if you try to heat water up, we're going to talking about idea called a specific heat capacity. To heat 1 kilogram of water to rise the temperature 1 degree Celsius, we need about 4.2 kilojoules of energy. But if you try to the latent heat of fusion, if you try to changing 1 kilogram of ice into water, you will need 335 kilojoules of energy. If you try to changing 1 kilogram of water into steam, you will need 2,260 kilojoules of energy. So you can see the latent heat of vaporization, it requires lots of heat energy. So here's something, you're probably gonna do a calculation. If you've been taking the foundation program, you learned this one. The formula is the energy equal to the mass times the specific heat capacity times the temperature difference. So C is the specific heat capacity. Delta T is the temperature difference. M is the mass. Let's say you have a electrical hot water tank. It's a 150-liter tank, and the city's incoming water at 15 degrees Celsius, and you need to heat the water. The required hot water temperature is 55 degrees. So we can calculate how much energy we require to heat them up. One thing you know or you don't know, for the pure water, 1 liter of water equal to 1 kilogram. That's the volume converted to the mass. So to heat that much water to 55 degrees, the energy required will be the formula M times C times delta T. 150 liter equal to 150 kilogram. Specific heat capacity, 4.2 kilojoules per kilogram per degree. The temperature changing, going to change it from 15 degree to 55 degree. So that's 55, subtract 15. Now become 150 times 4.2 times 40. Will give us number, where's my calculator? Oh. What happened to me today? $25,200 kilojoules. Make sense? Okay. So, That's the energy, right? What about a kilowatt hour? How steam? Yeah, we call that latent heat of vaporization. If you want to change in 1 kilogram of water into steam, that requires 20 to 60 kilojoules of energy. For those numbers, you don't have to remember them. Okay, if I ask you a question, I will give you those numbers. But you need to know how to do this calculation. You need to know how to do this calculation. Let's say we use an electrical hot water tank. So how many kilowatt hour is there? Did you guys still remember the conversion between kilowatt hour? Why I got such a quiet class? Looks like I always talking to myself. Okay, 1 kilowatt hour equal to 1,000 watts times an hour equal to 3,600 seconds, right? So that's equal to 3,600,000 joules. That equal to 3,600 kilojoules. What? You are an electrician, you didn't know this? Okay, if you know that, that's good. So 1 kilowatt hour equal to 3,600 kilojoules. So if I require that much energy to heat up the water, you can use that number divided by that to give you how many kilowatt hour, right? You Googled. Oh. So, wrong for the paper. Oh. The kilowatt hour equal to 25,200 kilojoules divided by 36 kilojoules per kilowatt hour. Give me 7 kilowatt hours. Okay. So far, so good. Do I lost anyone? Those is you learned all those in foundation. A million years ago. Yeah, I think Trevor told me this morning. He said he heard from a bunch of journey person. Lots of IP questions related to year 1 stuff. So if this hot water tank is rated for 5 kilowatts, how long going to take it to heat those water? That's right, 7 kilowatt hour divided by 5 kilowatts, 1.4 hours. Are we okay here? Yes, no? Move up. You can't see the bottom? Oh, okay. So there's on the working sheet, there's those type of calculation question. You need to do some practice because you will be tested on those things. Okay. Anyone have a question or you have a difficulty or something you need me to re-explain to you? So this is the formula. You need to know this is the calculation. Can I move on?
Yeah.
Okay. Thanks, Trevor. So another thing you either know or you don't know. When you're boiling water, at the normal atmosphere pressure, the water will boiling at 100 degrees Celsius. But if you add a reduced pressure, so like you guys go to the top of the mountain, you probably can boil, depends on how high that mountain is, you probably can boil the water between 80 to 90 degrees. Or you guys, you know those pressure cooker? If you have a higher pressure, anyone been using the pressure cooker before? When you increase the pressure, the boiling point also increase. So you might boiling the water at 110 degree or 120 degree, depends on how many pressure you build up there. The heat pump is try to using these features. The heat pump, one thing is the latent heat of vaporization. Did you guys remember the number I gave to you? For the water is a very high number, right? So to use this, because this latent heat of vaporization is a really big number. So what we do down here is you can see here. Let me show you the picture again. In here, because those vapor is in the gas state, you compress them to become a high pressure. So when the pressure is higher enough, they reach the boiling point. So those vapor gonna change in the state from the gas to liquid. Because the pressure is higher enough. The boiling point increase, so those vapor not gonna stay in the gas state anymore. They're gonna try to change it to the liquid. So when the vapor change it to the liquid, they have to give up those latent heat of vaporization. That's where they're gonna release lots of heat to the surrounding. So you will have those we call them the kind of like a fan kind of things. You will have a fan to push them. Then they have those radiator, have a low the aluminum fin making on there. So because they release lots of heat, and when those high pressure liquid, high temperature liquid goes through this expansion valve, the expansion valve going to control how much those liquid can passing through. So when those liquid passing through this expansion valve, they suddenly become a low pressure. When they become a low pressure, when the pressure drops, the boiling point gonna drop. And when the boiling point drops, those liquid at that temperature, they're gonna try to vaporize. They're gonna try to change the state from the liquid to the vapor to the gas. So when this liquid try to change it to the gas, they need absorbing those latent heat of vaporization. That's why they're gonna take in all the heat from the surrounding to vaporize. The heat pump is using this latent heat of vaporization, so they can absorbing lots of heat from this side, and they can deliver to another side. They can release those heat. And by using a certain type of chemical compound in there, because the water still you need 100 degrees, it's hard to reach. Those for the refrigeration cycle in here, those refrigerant inside the circulation, they usually will be boiling around 20 to 30 degrees. From the steam and the gas is we consider the same thing, or steam, vapor, gas, it's all the gas. So that's the basic thing, how a heat pump works. But for you guys, you'll have to know which one is absorbing the heat, which one is releasing the heat. Same thing like your fridge, right? Your fridge, you try to suck absorbing the heat from the inside, so you can keep the inside temperature lower. Then you're gonna go through the condenser. Condenser is usually at the back of the fridge. They're gonna release the heat to the room. Okay, so this is a very important picture, and the calculation for the hot water tank is very important. So you better know how to do those. So here's a picture showing your ice, water. You increase the temperature, your melting stage. Here's the latent heat of fusion. Then you can increase the temperature of the water. Then here's the mix of the water and the steam. Here's the latent heat of vaporization. Then here become the dry steam. You can keep increase the temperature, or you can go reverse this process. Specific heat capacity, that's where we use to do the calculation. So for the water, we calculate at 4.2 kilojoules per kilogram when you increase 1 degree. I think one calculation. Yeah, that's the one. So basically, it's very similar like you're going to calculate a hot water tank. Yes, that's the only one you need to do for this calculation. Okay, so for the ice, if you want to increase the ice 1 degree, 1 kilogram, it's 2.5, 1 kilojoules, or it's steam, you want to increase the temperature, so 1.9 kilojoules. So those are related to sensible heat, but the heat pump will use the latent heat. Here are some links down there. You can watch them. It's a Khan Academy. They will show you the calculation, how you can change it from ice all the way go to the steam. Okay, so when you actually want to install them, you gotta calculate. There's a lots of more calculation in there. You're gonna calculate the heating and the cooling load, and you don't have to do that as apprentice, but those one we're gonna do in the renewable energy course. So this part you don't have to worry about. Here is one of the lab equipment we had. It's for the geothermal heat pump. Here's your heat pump, and here's a bunch of pipe circulation down there, meters, and because we have to use it inside the lab, we cannot put the pipe actually drill holes go down to the floor. We use a large piece of water tank. We're using water inside. So those ground loop pipe is actually submerged inside the water down there. So they can take the heat energy or dump the heat energy inside the water. I guess that's probably all you'll have to know for, let me see, anything else in this one? Yeah, so I think for the apprentice, that's about it, because there's a more later, more complicated calculation for figure out all the sizing and everything. I'm not gonna be ask you guys as apprentice to do it. You just need to be able to do those basic calculation. Are we okay here? Yes, no?
Yeah.
Go back to the notes. Which one? Yes, this one we're not gonna provide to you. You gotta know this 1 kilowatt hour equal to how many kilojoules. 351549. I don't know your name. Which nodes you want to know? The previous one? The one before this? This one? Did you guys know if that guy Hayden is skip my class? I didn't hear he say anything. So I guess he's we got another 6. Hayden, you are here. You never say anything. You are so quiet today. Okay, a test question for you. What's
Trying
the
a
difference?
different approach.
What's the difference between a closed loop and an open loop geothermal system? Didn't want to answer my question? Yeah, that's the question for Hayden. To see if he can answer it or not. Maybe yesterday I abused him too much. He's so quiet now. Oh, no answer, which means he skipped my class this morning. Okay, we got another 15 minutes. How about can you guys open that BC Hydro's distribution generation requirement? Yeah, this document. So we're gonna go through certain things in here, which is important for you. You guys ready? I'll have this document. Yes, no?
Yep.
Okay. Okay, so this is if you want to connect any type of system into the BC Hydro's grid, you'll have to meet their requirement down here. Table of content. It's for you easy to find the information you're looking for. In here, they call this distributed generator owner, the DG owner. So first thing, you have to get approved from BC Hydro before you can do any interconnection. And for certain systems, they have to actually come to the site to test you. Some of them, they might not. They tell you how to use this document. Another one is that this document is not a replacement for the electrical code or other standard. They will refer back to the electrical code and the standard a lot. So in here, you got to be careful down here is they said a BC Hydro's distribution system. So the hydro utility network, they will also have a range of parameter fluctuations. They list down here. So here is a BC Hydro system. So when you answer the question, you gotta be careful because when we ask you, is your system, this is on BC Hydro system. They certain things, they give them a wide range there. They allow you to go in there. Frequency, 60 hertz is between 59.7 to 60.2. So this is a pretty tight frequency range. The voltage, the normal operation, the extreme voltage. Usually you can have a little bit of lower voltage, but you cannot have a too high a voltage. So that's for them. The harmonic, it's also smaller 8%, smaller 11%. One is for short term, one is for long term. So this is for BC Hydro's utility network. They will experience those kind of fluctuation, but when you have a system connecting there, you got to be checking other place. You cannot use those numbers. First, what's a simple distribution generator? They will give you a definition. You have to meet all those requirements to be classified as simple distributed generator. It's an inverter-based system. And this inverter have to be certified to those CSA standard. So, which means if you have a solar panel or if you have a wind turbine, or you try to changing whatever, because the solar panel you have a DC, you have to converting inverter that DC into AC. So that's the inverter-based system. You have a wind turbine, you might generate a voltage and the frequency at a different than the hydro's utility grid. So you will use the inverter to synchronize with the hydro grid, but those inverters have to be certified. And the rating is 27 kilowatt or less. So they give you the number 30 kVA at 0.9 power fact. You have a self-contained revenue meters. So those ones for 200 amp or less, now 600 volts, 3-phase, 3 wire. So you have a self-contained revenue meter. You meet all those requirements. It's considered simplified distribution generator. Then they will give you a little bit less linear on your requirement to connection. Point of common coupling, that's where you're going to connect to your system into the BC Hydro. So this is typically at the weatherhead for overhead service or at the revenue meter base for underground service. Disconnect means your generator require a safely disconnect mean to ensure isolation. And also you need to have a warning label at the revenue meter location. The disconnect means with a single line permanent legible diagram of how the system installed have to be in a conspicuous place to show people, if people go there, they know what's going on for the safety reason. Another one, this is a very important thing. They call it anti-islanding. They have a CSA standard requires if you have an inverter-based system, you have to cease energizing the distribution system within 0.1 seconds when you lose BC Hydro power supply. There's also a table down there. We list this number for you. It's for the safety of electrical work and the public. What this means is, let's say you have a house, you have a renewable energy system. So you have a PV panel or you have a wind turbine. You are generating the electricity for your house using. At the same time, you are interconnecting to the BC Hydro's network. So when you have extra energy, you might be able to feed back to the BC Hydro's network, and you have those either do metering or net metering, so that they will recording how much energy you're using from the BC Hydro, how much energy you're feeding back to them. But if for something happen, let's say some maybe a tree branch hit a hydro power line, or maybe someone driving a car, he's drunk, he hit a power pole. So for that portion of BC Hydro's network, they lost power. When they lost power, there's a bunch of neighbors gonna lose power at the same time, and the hydro gonna send some guy to do the repairing. So when your inverter or your system detects the hydro power line lost power, mostly for voltage, right? You test the voltage. If the voltage drop below whatever the value, you're gonna think, okay, the hydro power line is lost power. They don't have the supply anymore. Your inverter or your controlling system, you have to disconnect from the hydro system. You can still feed your house. You can still light up your house, feed energy to your house, but your inverter or your controlling equipment have to be disconnect from the hydro power line. Because if you keep feeding the power back onto the hydro line, it's gonna be a danger to the hydro repair person. That makes sense?
Yeah.
So that's a very strict requirement for the safety, for the BC Hydro, for the CSA standard. A great interactive inverter, they might containing those internal disconnect and the transfer switch to ensure the isolation from BC Hydro's distribution system, while still supplying essential load panel. So that means those inverter, they can still supply the inside of your house or your building, but they will disconnect from the hydro. So that's a very important thing to know. Usually they also ask you to keep a maintenance record, and because if you can't provide those things, they might disconnect you from the hydro network. Okay, next one is a complex distribution generator. You could be an inverter-based generator, but you are not certified to meet the CSA standard. So they still allow you to use that, but you got to consider as a complex distribution generator system. Or your nameplate rating is greater than 27 kilowatts. They allow you all the way up to 100 kilowatts. If you go over 100 kilowatts, you are not, you will be considered as a utility supply company. So they don't want you to connect anything more than 100 kilowatt into the system. If you have big system, you are selling power to them, you gotta talk to them individually. This guy does not apply. Or if you're using induction or synchronized generator, because you supply more power in this case, your service is greater than 200 amps now, you cannot use the normal revenue meter. You have to use instrument transformer revenue metering. So you will have a PTs, CTs, those in your service. Then all those in is considered complex distribution system. If you have a complex system, the application document and the drawing have to be approved and sealed by a professional engineer registered in BC. So large system, you need to get a professional engineer to approve. Point of disconnection, almost the same. You have to follow the code, section 84. Labels, warnings, those things, it's the same thing. Your system must be grounded if you're using generator. The anti-islanding requirement is the same. You have to disconnect your system within 0.1 seconds if you lost BC Hydro's power. The synchronization, the synchronized generator, automatic synchronized capability to connect in parallel with BC Hydro system. Power quality. So we look at before the hydros network, they can have 8% or 10% harmonic, but for you, if you want to connect onto the BC Hydro, you cannot exceed 5% harmonic current. Same thing, the maintenance record have to be kept. Then the appendix, down here, they will tell you different type of inverter, gray tile, gray dependent, gray interactive. So those inverter, even I highlight them, I just try to mention the different type of inverter. You don't have to know each detail down here. They give you the drawing. They try to shows you where's your local loads, where's your distribution generator, interconnect system, where's the point of connection, where's the point of common coupling. And for your inverter, they will require you to have a bunch of function, those protecting, anti-islanding, synchronized under voltage, over current, over voltage, over frequency, or under frequency protection. So this is a single line diagram, typical system. So for your interconnection down here, you have to provide in those protections. Warning label, the size of the warning label. Service entrance voltage variation limit. So if you're providing single phase 120 to 40 volts, what's the minimum voltage? What's the maximum voltage? This table will give you all the detail. Interconnection protection function required for inverter-based the system. So depends on single phase or three phase, what's the rating, what type of function you have to provide. Inverter base respond to abnormal voltage. You can see here, this is the maximum number of cycle to disconnect, 6 cycle, because we have a 60 Hertz frequency down here. Each cycle gonna be 16.67 millisecond. So 6 cycle is close to 100 millisecond. That's matching with the requirement. You have to disconnect in 0.1 seconds. Here's the maximum harmonic current distortion. For individual harmonic order, this is the total harmonic distortion is smaller than 5%, so maximum 5%. I like to finish this document. We probably just gonna take another few minutes, and we can come back a few minutes later if you guys okay.
Keep going.
Okay, so the total harmonic distortion have to be maximum 5%. Here is the harmonic order. This is a harmonic smaller than 11. So if smaller than 11, you can have maximum 4%. So if I ask you a question, I said, what's the maximum third harmonic you can have? Is 4%. Okay, but all of them adding together, it's a 5% maximum. The frequency operation limit, So if you're smaller than 27 kilowatts, your lowest frequency, 59.5, highest frequency 60.5. If larger than that, and that's the range there. If you're over the range, you have to disconnect your system from the BC Hydro. So that's the limit for your frequency range. Typical measurement location of voltage and frequency for protection function. We normally, for the renewable energy system, is always inverter-based system. So it's the point of measurement is at the AC output of the inverter. That's where we're gonna take those measurements. I think that's all for this document. So there will be few questions. I'm not sure, maybe 3, maybe 2 from this document. And when you're doing the exam, you probably want to have this document handy. Okay, should we take a lunch break and come back at 11:35?
Sounds good.
Okay, see you guys at 11:35. Hayden, don't make me come to your home to give you a private tutoring. Okay, see you guys.